All right, now we're going to talk about another special type of special right triangles, and we'll call this traditional 30, 60, 90 triangle problems. Okay, and let me zoom in just a little bit. All right, there we go. All right. So what we're going to start with, we're going to have a 30, 60, 90 triangle. And that means that this angle here is 90. We'll say this one is 60, and this one is 30. And let's just put a number right here. All right. And then let's think about how can we find the other ones. Now we can actually find all of these sides even though we only have one side length. It might not be obvious and you have to kind of really think outside the box. But what you can do is let's kind of reflect this triangle over this line and draw the same triangle on the other side. Now this angle was 90 here, so this will also be 90, which means this is a straight line at the bottom. Guess what this angle is going to be? If you guessed 60 degrees, you are correct. And guess what this angle is going to be? If you guessed 30, this is correct. Now, put all the way together, this is a special triangle. Not only is it two of the angles are the same, so it's definitely isosceles, but if you actually add these two angles together, 30 plus 30 is 60, you see all three angles are the same. That means all the sides are the same. So this is 8, this is 8, and then this whole thing is also 8. Does that make sense? And we already know that when you drop an altitude in an isosceles triangle, it splits, it bisects the base. So if the whole thing was 8, this is going to be 4. Okay? So let's go back to our original triangle because I think it'll be a little bit easier. But that's the thought. If you ever have a 30, 60, 90 triangle and you know the hypotenuse is 8, you can go through this process, but the short leg, as it is called, will always be half the hypotenuse, okay? Because you can go through this process. We still need to find this side. This side is called the long leg. So this is the short leg because it's shorter than the long leg, and this is always the hypotenuse, and we'll use those terms often. Pause the video real quick. Try to use Pythagorean theorem in this case and see what you get for this. So I'll give you a moment, pause the video, and attempt the problem. All right, hopefully you had a chance to do that. So this is going to be a squared plus b squared equals c squared. And in this case, my hypotenuse is 8. So C will be 8. 4 times 4 is 16. 8 times 8 is 64. Subtract 16, and x squared equals 48. Now we're going to need to take the square root of 48, and that means we're going to have to do the factor tree. We'll do the factor tree over here because I think it'll be easier. I like to do 6 and 8, 3 and 2, 4 and 2, 2 and 2. And again, I'm sorry if I'm going quickly, but I do feel that this is a video, so you can go back and watch it over and over again if you need to. So I'm going to go a little bit quickly because I know that you can watch it again. All right, so this is going to be 3 times 2 times 2 times 2 times 2. Woo! All right. Cross it out twice, write it down once. Can we do it again? Of course we can. Cross it out twice, write it down once. Can we do it again? No. So what stays in is the 3. So when we clean this up, 2 times 2 is 4, radical 3. And this is what our triangle looks like. All right. So let's do one more. And again, let's do 30, 60, 90. And let's say this one is 3. And let's try to find all the other sides. Again, in a 30, 60, 90 triangle, we'll be able to find both of the missing sides, even if we only have one side. Whereas in the past, we needed to have 2 sides to use Pythagorean theorem. Now, the reason, again, why is because I can kind of extend this to get my isosceles triangle like we had up here. And if this part was 3, this part would be 3. And this is an equilateral triangle, so the whole side would be 6. This will be 6. So if you are given the short leg, the hypotenuse is twice of that. So just like here, 4 times 2 is 8. 3 times 2 is 6. All right, so let's do, and I'm going to kind of just do this. And I'm going to erase this for now. All right, I'm going to kind of use some of this space here so that you can see the previous example still. So a squared plus b squared equals c squared. This will be x plus 3 squared equals 6 squared. Again, the hypotenuse is 6. X plus 9 equals 36. And we are going to subtract 9. So x equals 27. X squared, I'm sorry, I missed all my 2's. And now we're going to do the square root of 27. Now, again, and I'm going to just use this space over here to do my factor tree. So 27 is 9 times 3. 3 is prime. This one is 3 and 3. All right, now I'm going to cross it out twice, write it down once. And this is my final answer. Okay? All right, so just like before, there is a pattern here. Take a look at this triangle. Take a look at this triangle. And we'll do one more very quick example. So now I'm going to switch the orientation. The first two were oriented the same. This one will be a little bit different. And let's do 10 right here. And this is 60. And this is 30. So take a guess. What is this leg and what is this leg? Looking at the pattern, what will our pattern be? Now, the fact that it's oriented differently makes it a little bit more challenging, but let's think of it like this. So what is 10? Is 10 the hypotenuse, short leg, or the long leg? Well, 10 is the hypotenuse. So we're starting at the hypotenuse. Okay? Now, if we know the hypotenuse, we can find the short leg. How do we get from here to here? Well, look, how do I get from 8 to 4, 6 to 3? Well, half of 8 is 4. And half of 6 is 3. So half of 10 is 5. Now it has to go on, the short leg is half of 8. Which one is the short leg? Is it the one on the left or the one at the bottom? Well, clearly the short leg is the one on the left. It is shorter than the other leg. So this is going to be 5. Now how do we find the long leg? Notice the long leg in each scenario has a square root of 3. And it has a number here. And what does this number come from? Well, it looks like it comes from the short leg. So here we have a square root of 3, and 3 is the length of the short leg. So we're going to take the short leg, and we're going to multiply it by square root of 3 to get the long leg. So here's the short leg, multiply it by square root of 3 to get the long leg. So this should be 5 square root of 3. And again, we are done, and we don't need to do Pythagorean theorem, okay? So we will do a couple quick examples using this pattern. But first, let's maybe write down some rules. So when you have a 30, 60, 90 triangle, first of all, the hypotenuse is always the hypotenuse. I'm just going to put HYP for hypotenuse. And then you have to decide which one is the long leg and which one is the short leg. But it's fairly obvious because the short leg is shorter. It looks smaller than the long leg. So which one do you think is the short leg? If you guessed this one is the short leg, congratulations. You are correct. And this one is the long leg. Okay, are we okay with this so far? All right. And the rules are, there are kind of three rules. Number one, the hypotenuse is twice the short leg. I think there's really two rules. So the hypotenuse is twice as big as the short leg. Now the other unwritten rule here is that means that the short leg is half the hypotenuse. So that short leg is half the hypotenuse. That's kind of the converse of this statement. The other rule is the long leg equals the short leg times square root of 3. So here's the short leg. The long leg equals the short leg 3 times the square root of 3, and we see it here. Now the converse of that would really be that the short leg is equal to the long leg divided by the square root of 3. That would be the opposite of that, right? But what that really ends up meaning is that you take the long leg and you get rid of, if I divide this by square root of 3, if I have this and I divide it by square root of 3, what ends up happening is these cancel out. So if I divide 3 square root of 3 by the square root of 3, I end up with what I want. But an easier way to think about it is if you have the long leg and it has a square root of 3, just get rid of the square root of 3 and you will be good to go. All right. So again, let's do 3 quick examples and let's write a quick diagram that will help you. And I'm kind of purposefully orienting the triangle differently because it will be oriented differently in different problems. So I want you to get used to that. But a general rule is, again, one thing I want you to notice is which part shows up in number 1 and number 2. Is it the hypotenuse that's in both? Is it the short leg or is it the long leg? The short leg is the answer on that one. And that means that you always want to find the short leg first if you don't already have it, because you can use the short leg to find everything else. And if you know the hypotenuse, you can find the short leg. If you know the long leg, you can find the short leg. So we're going to call the short leg x. Then whatever that number is, this will be x square root of 3. In fact, I don't want to call this s. I want to call it s for short leg, so you remember that it is the short leg. And this will be 2 times s. Okay? And that might help to just have handy as you do some of the problems. So let's do 3 examples. All right. All right, first thing you want to do when you have a problem like this, and you know it's a 30, 60, 90, identify what is this 6 measuring? Is it the short leg, long leg, or the hypotenuse? In this case, it is the short leg. So let's go to either over here, whatever you think makes the most sense. But basically, the hypotenuse is twice the short leg. Or if I look over here, if this is s, this will be 2 times s. So 2 times 6 is 12. And then the long leg is equal to the short leg times square root of 3. So here's my short leg. And so I'm just going to multiply whatever that number is times square root of 3. So I'm going to do 6 square root of 3. And you are done without having to use the Pythagorean theorem. Let's do a different one. All right, so I'm going to do 14 here. Okay, so again, first step, identify what do you have. Well, I have, is it the short leg, long leg, or the hypotenuse? That is 14 units long. In this case, it is the hypotenuse, okay? So that means the hypotenuse, remember the hypotenuse is twice the short leg, right? So the hypotenuse is twice the short leg. So if this is 12, the short leg would be 6. So if this is 14, what I'm really going to do is I'm going to divide it by 2. 12 divided by 2 is 6. 14 divided by 2 is 7. And you always want to find the short leg first, if they didn't already give it to you. So find the short leg first. It is really the key. All right, so now let's find the long leg. What will the long leg be? Well, the long leg is going to be the short leg times the square root of 3. So this will be 7 times the square root of 3. Right? So the short leg times the square root of 3. So if this is 6, this is 6 radical 3. The short leg is 6. This is 6 radical 3. If the short leg is 7, this is 7 radical 3. All right, we're going to do one more example. All right, and so let's do 13 square root of 3. All right, what are we given? Is it the short leg, the long leg, or the hypotenuse? Think about it for a moment. If you are feeling like this is the long leg, you are correct. This is the hypotenuse. It's across from the right angle. And this is longer than this. These are the two legs. This is the long leg. This is the short leg. So if I start, again, what do we want to find first? The short leg. So how do I get from the long leg to the short leg? How do I get from the long leg to the short leg? Basically what I do is I get rid of that square root of 3, right? Does that make sense? So 6 radical 3 without the square root of 3 is 6. 7 radical 3 without the square root of 3 is 7. 13 radical 3 without the radical 3 is 13. And now I can find the hypotenuse because I know the short leg, and the hypotenuse is twice the short leg. So I know my short leg is S. This will be 2 times that number. So 6 times 2 is 12. 7 times 2 is 14. 13 times 2 is 26. And you are done. All right, and we will do non-traditional 30, 60, 90 triangles soon.